Hello, my name is Sam, and I'll be talking about the interactions and interplay between climate change, climate science, and the space industry. The first thing I found that was fascinating was that this topic of rocket emissions actually isn't very thoroughly researched. And this is because historically, rocket launches have actually been decreasing quite significantly since the 60s and 70s during the Cold War. However, this is post a change, and now they're increasing due to the advent of technological developments and the prospects of commercial spaceflight by companies like SpaceX, Blue Origin, and Virgin Galactic. Currently, there are hundreds of launches per year. However, in the near future, this is projected to reach into the thousands. The primary concern is gases and particulates emitted directly into the stratosphere during launch, known as rocket soot, which is comprised of aluminum oxide and black carbon. Aluminum oxide is also known as alumina. Alumina is known to absorb radiation, which heats the stratosphere while simultaneously cooling that lower atmosphere. However, this heating of the stratosphere facilitates chemical reactions that have the potential to damage the ozone layer and lead to ozone loss. However, interestingly, there is conflicting research on what these particles actually do, and models require very many complex interactions and iterations to accurately model, and it's not really a current focus of climate research for reasons I'll go over soon. Rocket emissions aren't thoroughly studied because, in comparison to other sources of carbon, they're somewhat negligible. For example, currently aviation makes up 12% of all carbon emissions, road transport 74%, and rocket launches produce about 3.1 million tons of carbon per year. For comparison, there are 1.42 billion passenger vehicles on the planet, which are estimated to produce 4.6 tons of carbon per year each, resulting in a total of around 6.5 billion tons of CO2 per year. Ironically, satellites, which are launched into space by rockets and produce rocket emissions, are extremely important for imaging and studying the impact of climate change and general climate trends. One such satellite is NASA's Global Precipitation Measurement Satellite, GPM, which studies general changing weather patterns and flooding. Currently, there are over 2,200 satellites orbiting Earth, and this number is expected to increase, with SpaceX's Starlink missions requiring over 1,200 satellites alone. However, there's something else up there with the satellites. And that something would be space debris or space junk as it's referred to by NASA. Right now, there are more than 500,000 pieces of debris or space junk that are being tracked by NASA and other agencies. Miraculously, there's only been a few bad collisions, as satellites are able to avoid this debris, but at the cost of fuel, which as we learned in class can be very expensive and wasteful. However, in the future it is projected to become a problem for launches, as the number of space debris that is large enough to entirely destroy a spacecraft or satellite has doubled in less than 25 years. And single events can prove disastrous to adding to the amount of debris in space. For example, in 2007 a Chinese anti-satellite test destroyed an old weather satellite, which resulted in the creation of 3,000 new pieces of space debris. What goes up must eventually come down, and as the orbits of the space debris destabilizes, they'll burn up and vaporize the heavy metals that are contained in these complex computer systems, including chromium, lead, beryllium, cadmium, and generally other heavy metals that you definitely don't want vaporized into the atmosphere. And once again, the effects of these vaporized particles is still not very well understood. In conclusion, I was somewhat shocked about how little research had actually been done on the topic of rocket emissions. As the space industry is no longer small and stagnant, and as more businesses look to the stars, I believe it will be incredibly important to understand how the rocket emissions by these launches affects our climate and us down here on Earth. While becoming a interplanetary species, as per Elon Musk's plan, is very fun and a great idea, I think it would be more practical to focus on Plan A, which would be saving the planet we currently have, as it's the only one we have for sure. As engineers and people who will be living through the next 50 years, I believe is incredibly important to understand the effects that our prospective industries will have on the climate. Others in the past have known about climate change and done nothing about it in the interest of business. This is incredibly pressing now, as of November 5th, 2020, the Siberian Arctic sea ice has yet to freeze for the first time in recorded history. This puts us on a very alarming trajectory towards something known as a blue ocean event, in which there is too much thermal energy in the atmosphere and the oceans for the sea ice to completely freeze, creating a phenomenon known as Arctic amplification, which increases the magnitude of global warming we'll be experiencing in the coming years. I hope you learned something and stay safe out there. Here are the resources I consulted for this presentation.